sugod na ta.
Problem. For the circuit shown, obtain V1 and V2. So we have here your circuit. Your node 1 is denoted as V1 and your node 2 is denoted as V2. So to solve for that circuit, first, let us assume the current flowing to our resistance. Let's say this would be your I1. This would be your I2. This would be your I3. This would be your I4. So at node 1, you have current entering of I1 minus you have the leaving current of I3, I2, and 6 amperes. So that will be minus I2, minus I3, minus 6 amperes is equal to 0. So for your I1, you have your tails voltage minus the head's voltage. So you have 0 minus V1. 0 because it is directly connected to the ground, divided by the resistance, which is 10, minus, for your I2, you have V1 and V2. So V1 minus V2 divided by the resistance, which is 2, minus, for your I3, you have V1 and 0. You have V1 minus 0 all over the resistance, which is 5 ohms, is equal to, so transpose the constant number to the right hand side, so you have equal to 6. Then simplify the equation, so you have 0 over 10, 0, so this is negative 1/10 V1, so negative 1/10 V1 minus 1/2 V1, negative times negative, so you have plus 1/2 V2 minus 1/5 V1 is equal to 6. So combining like terms, we have 1 over 10, negative 1 over 10, minus 1/2, minus 1/5, so you have negative 4/5. V1, then plus 1/2 V2, is equal to 6. This will be your equation 1. At node 2, we have a current entering of I2, 6 amperes and 3 amperes. We have 6 amperes plus I2 plus 3 amperes minus the leaving currents. You have I4 is equal to 0. Then substituting the nodal current equivalent for your I2 and I4. So for your I2, you have V1 minus V2 divided by the resistance 2 ohms. So you have V1 minus V2 divided by 2 ohms minus I4. So you have, for your I4, you have V2 minus 0 divided by 4. You have V2 minus 0 divided by 4. Then is equal to constant. So 6 plus 3, that is positive 9, transpose to the right hand side, so that will be equal to negative 9. Simplify the equation, so you have 1 half V1 minus 1 half V2 minus 1/4 V2 is equal to negative 9. So combining like terms, you have 1 half V1 negative 1 half V2 minus 1/4 V2. So you have negative 3/4 V2 is equal to negative 9. So this will be your equation 2. So you have now your equation 1 and 2. So writing it in the equivalent matrix form, so you have negative 4/5, 1 half, 1 half, negative 3/4, multiplied by your unknowns, V1 and V2, is equal to the constant 6 and negative 9. So solving for your V1 by Kramer's rule, so we have V1 is equal to, replace the first column by your constant elements, so you have 6, negative 9. Copy the second column, so you have 1 half, negative 3/4, divided by this matrix, so you have negative 4/5, 1 half, 1 half, and negative 3/4. Next, solve for each determinant. So you have 6 times negative 3/4 minus, you have negative 9 times 1 half all over, you have negative 4/5 times negative 3/4 minus 1 half times 1 half. So your V1 is equal to 0 volts. To solve for your V2, still by Kramer's rule, so you have V2. Copy the first column, so you have negative 4/5 and 1 half. Replace the second column by your constant values, so you have 6 and negative 9. Then divided by the same matrix, so this 4/5, 1 half, 1 half, negative 3/4. Then solve for its determinants. So you have 4/5 times negative 9, negative 4/5 times negative 9 minus, you have 1 half times 6. Next, all over, we have negative 4/5 times negative 3/4 minus 1 half times 1 half and your V2 is equal to 12 volts. So this will be the value for your V1, and this is the value of your V2.